Good evening, students. Welcome in next lecture of Math F242 Operation Research. Audio is okay? Anyone please reply? Okay.
Yes, sir.
So in morning we have studied the few theorems related to exponential distribution because in course we have the Poisson Q, and for the Poisson Q basic condition are arrival inter-arrival time as well as service time should follow the exponential distribution. So next theorem in continuous of that, next theorem is if T1, T2, Tn are independent exponential variate with parameter mu, mu1, mu2, mu1 respectively, then minimum of T1, T2, Tn is also an exponential variate with parameter mu1, mu2, mu1 plus mu2 plus mu1. So in this case, it is given to you that Ti follow the exponential distribution with parameter mu I, where I is equal to 1 to n. Now we define the new random variable t as minimum of t1, t2, right, t3, and tn. If you define the new random variable, since it is a function of the random variables, so it is also the random variable, or you can say it is the continuous random variable. So now we have to determine the PDF of this distribution. So here we compute the CDF of the we compute the CDF of the current value. So ft is what? Probability that t less than equal to t, right, for the t greater than equal to 0. Means here we compute ft. What is the meaning of this? T less than equal to t, and capital T is what? It is the minimum of t1, t2, and tn less than equal to t. This is equal to 1 minus probability of minimum of t1, t2, tn greater than equal to t. So if the minimum of t1, t1, t2, tn greater than t, then all the values are right. All the ti's are greater than equal to t. That implies t1 greater than equal to t, t2 greater than equal to t, and tn greater than equal to t. Right? It means what is this? This is the intersection. This is the intersection. This is the intersection. And t1 greater than equal to t, and t2 greater than equal to t, and tn greater than equal to t. Since t1, t2, t1, t2, tn are independent. So this will become 1 minus probability of, we know that if if something is independent, then probability of A intersection B is equal to what? It is the PA into PB. So using the same theory, we have the T1 greater than equal to T, P of T2 greater than equal to T, and P of Tn greater than equal to T. And it is given to you Ti follow the all the Ti's follow the exponential distribution with parameter mu I. So this will become 1 minus, now what is the value of the T1 greater than T? It is the f of T, right? F of T corresponding to variable T1. So this will become e to power minus mu1 T. Mu1 T, this will become e to power minus mu2 T and e to power mu n T, which can be written as 1 minus e to power minus mu1 plus mu2 plus mu n into T. And what is this? This is the CDF of exponential distribution with parameter mu1 plus mu2 plus mu1. The same thing we have here in the theorem. Clear? Any doubt? Anything you want to ask? Now, theorem 7.6. So it is the SMA, whatever the Poisson process you have studied. If the inter-occurrence time of event are independent exponential variate with same parameter alpha, with same parameter alpha, with same parameter alpha, then for any t naught greater than 0, for small delta t greater than 0, probability no occurrence of the event in the interval I will be the 1 minus alpha into delta t. The same thing we have studied. Probability more than one occurrence is higher power of the delta t, and exactly one occurrence is the alpha into delta t. So if it is the state dependent, so instead of the alpha we take the alpha respective alpha, right? We take the alpha k or respective alpha. So it is exactly the same theorem whatever we have discussed for the Poisson process. Now most important part of the birth means queuing theory is the birth and death process. So here we define birth and death process is defined by the following axioms. As I have told you earlier also, axiom is the statement, true statements which do not require the proof. We assume that it is always true. So birth and death process we defined using the following axiom. What is the axiom 1? Axiom 1 is given nt is equal to n, means n is the random variable, means there are n customer in the system at the time t. So nt is equal to n given that there are n customers in the system at the time t. The conditional probability distribution of time until the next birth is exponential with parameter lambda n t, lambda n, right, up to lambda n, and here n is equal to 0, 1, 2 and so on. So what is the meaning? That if there are n customers, 0, 1, 2, and here we have the n customers. So next customer will come. It means there will be the n plus 1th customer. So next customer will come with the rate lambda n. And inter-arrival time follow the exponential distribution with parameter lambda n. That is the axiom 1. If you feel any doubt, please open your mic and ask immediately. Axiom 2, axiom 2 given nt is equal to n, the conditional probability distribution of time until the next death is exponential with parameter mu n, and n is equal to 1 to so on, and mu 0 is equal to 0. Thing is, if there is n customer, if there is n customer in the system, and he will get the service, he will get the service, so it will become the n minus 1 customer, and the service rate will be the mu n. Means it is the lambda n, and mu n is what? Earlier also I have told you, it is the state dependent rate. They are the state dependent rates, right? State dependent rates means it depend how many customers are there, right? It is the rate, right? Rate when nt is equal to, when nt is equal to n, depend over the condition. So here the service rate is this. So here also the service time follow the exponential distribution with parameter mu n. Then axiom 3, only one birth or death can occur at a time, because in the Poisson process you have seen, at a time only, at a time only, one event can happen. More than one event is zero. Probability for occurrence of the more than one event will be the zero. So at the particular time, in the small interval of time, either we have only the birth or death. Simultaneously, two birth cannot happen. Simultaneously, two death cannot happen, or simultaneously birth and death cannot happen. We assume that either only birth or only death can happen in that small interval of time, right? Interval of time of length delta t. Axiom 4, birth and death occur independent of given population. Means presently how many people are there, it is independent of that. So here what you can understand, why we are calling as a birth, right? Birth and death. So here the birth define means it is the arrival, and death means it is the departure, right? It is a departure. So here in the service system, in the queuing system, either we have the arrival of the customer or the departure of the customer, so that we nomenclate as birth and death of the customer. That's why its name is the birth and death process. So with the birth, with the arrival, always there is an increase in number of customers, and due to the death or departure there is decrement in the number of customers. So departure will happen after the service, departure happen after the service, right? And arrival occur for the sake of the service. Clear? So birth and death process defined by the following axioms. Is there any doubt to understand this axiom? Axiom is the statement we assume as a always true statement.
So in the third one,
Yes.
why can't one arrive? So one customer arrives and at the same time a customer will leave, right? A customer can arrive only when the another customer who took the service leaves, right? So birth and death are occurring in the same time, right? Why can't that not be
No,
possible?
no. Actually, in that case, we have this thing. Probability more than one occurrence of event in the interval will be the zero. So
So are we assuming that this
means there is the occurrences of the two events, one birth, one death. So more than one event cannot happen.
so this is our assumption, right? I mean, in this.
Ha, so
So
that is not that we are assuming. Axiom is the assumption which is always true, which do not require any proof.
okay, sir. Understood.
So actually, what happened here? Initially, always there is zero customer. So this circle denote the state of the system, right? This circle denote state of the system. State of the system. State of the system means how many customers are there. So initially there is the zero customer. Now the first customer arrive with the rate lambda naught. So now there is one customer. Now second customer arrive with the rate lambda 1, right? Because there is one customer. Now second customer is arriving with the rate lambda 1. Similarly, the third customer will arrive with the rate lambda 2. Means lambda naught, lambda 2, lambda 1, lambda 2 are the state dependent rate. State is what? There are so much customer. So if you continue, so at one situation there are n minus 1 customer, and then we have the nth customer. So that will come with the rate n minus 1, lambda n minus 1. Now we have the n plus 1 customer. So the arrival rate will be the lambda n, and so on. Now that's why if you minute thing you have to note here, very important thing. General you do the mistake. That's why here we have written the lambda n start from the 0, 1, 2, 3, because the first customer arrives only when there is the zero customer, right? So that's why we are starting this n from the 0, 1, 2. Thereafter, if there is one customer, then you provide the service with the rate mu1. If there are two customers, then provide the service with rate mu2. If there are the three customers, provide the service with the rate mu3. As you are providing the service, the number of the customer will reduce. So state of the system will change. Here we have the three customers. Now here we have the two customers after getting the service. And here we have the mu n, and here we have the mu n plus 1, and so on. Clear this part? So here the mu1, mu2, mu3, mu n plus 1 are the state dependent service rate. So here you can notice, in case of the mu n start from the 1, right? N start from the 1. Why we are starting from the 1? Because you are providing the service when there is at least one customer. You cannot provide the service to the 0th customer. For providing the service, there must be at least one customer. That's why here we are taking the mu naught as a 0. Clear this part? So this type of the diagram is known as the transient rate diagram, or transient state diagram, or state transition diagram. We call it as a state transition diagram also. State transition diagram also. Now from this state transition diagram, we develop the governing differential difference equation. So how we can develop? So here, as I have told you, the meaning of the worth is the entry of the customer in the system, or arrival of the customer in the system. Means entry into the system, and with the birth always there is increase in the number of customer. That here define the departure after having the service, and due to the death always there is the decrement in the number of customer. And what are the lambda n and mu n? lambda n and mu1 are the state dependent arrival rate and state dependent departure rate. What is the state? State will be the number of customers. Means the arrival or departure rates depend over how many customers we have in the system. So lambda n and mu n represent respectively the instantaneous mean arrival rate and the mean service rate. Mean service rate of the system at the instant t when the state of the system is n. State of the system is n means nt is equal to n. Delta t denotes the small increment in the time interval. Means we are talking for the t plus delta t. Now, now we define we define the few probabilities. Probability no worth in the small interval t to t plus delta t. Given that this is the given that nt is equal to n. What will be the answer? That what I am asking if the inter arrival time follow the exponential distribution, right? So if the nt is equal to n, if nt is equal to n, what is the probability that there is there is one arrival one arrival given there is given there is n customers, there is n customers that you have to determine. Means there there is n customers, there is n customer, and there is one arrival in in interval t to t plus delta t, in interval t to t plus delta t. So from the previous theory, what will be the answer? From the now one arrival means one event. One arrival means one event. So when we are asking for the one event, exactly one event, exactly one occurrences, what will be the answer? Answer is alpha into delta t. And here we have so it is the lambda n, because at that time rate is the lambda n. When there is there are the n customers, when there are n customers, at that time the lambda rate is the lambda n, lambda into delta t plus higher order of the delta t. The same thing we have written in the slides, right? Exactly one event, lambda n into delta t. Lambda n is equal to delta t. First I have derived this exactly one worth in the interval t to t plus delta t, given that there are n customers. Exactly one worth in the interval t to t plus delta t, where delta t is very small, given that there are n customer. So it is equal to lambda n into delta t. Similarly, exactly one death, exactly one death, exactly one death in the interval t to t plus delta t, given that there are n customers. There are n customers, it will become the mu n. Mu n is means instantaneous service rate or state dependent service rate when there are n customers. Mu n delta t plus higher order of the delta t. Exactly one death. Now, if I say, what is the probability that no worth in the small interval? No worth in the small interval. Probability there is no birth. There is no birth. No worth in interval t to t plus delta t. T to t plus delta t given there are n customers. There are n customers. Right? So there are n customer means nt is equal to n. Probability there is no worth. So there is no worth. So we know that from this theorem, no occurrences. No occurrence of the event in the interval I is equal to 1 minus alpha delta t. So 1 minus alpha delta t means it is equal to 1 minus lambda n delta t plus higher order of the delta t. Similarly, probability there are more than one worth, more than one worth in interval t to t plus delta t given there are n customers. Given there are n customers, so in this case it will be from the theorem. From the theorem, there are more than one occurrence of the event. It is the higher order of the delta t. So it is higher order of the delta t. So if I want probability there is no birth, no birth and no death, no birth and no death in interval t to t plus delta t, t to t plus delta t given there are n customers. There are n customers. So at that time, because here no event is occurring, neither birth nor death, no event is occurring. So that is possible. So in this case, when we say no birth, no death, so no birth, no death, so no occurrences. It means no occurrences. No occurrences will be the 1 minus alpha delta t. Alpha delta t. So this will become, additive property of the Poisson distribution, right? If x1 x2 follow the Poisson distribution, then their sum x1 plus x2 also follow the Poisson distribution with the rate or with the parameter of x1 plus parameter of the x2. So this will become 1 minus lambda n plus mu n. First here we add the rate lambda n plus mu n into delta t plus higher order of the delta t. So is there any doubt to understand this? No worth in the small interval. It is the 1 minus lambda n t. Two or more worth. It is the higher order of the delta t. Exactly one worth lambda n into delta t plus higher order of the delta t. Exactly one death lambda n delta t plus higher order of the delta t. No worth, no death. No worth, no death. It means this is the 1 minus lambda n plus mu n into delta t. Clear how we are writing this? From the basics of the means from the axioms, from the basics of the exponential distribution, I am writing this. Is there any doubt to understand this? Anyone? Now, if I say this is the t, this is the timeline. At this point, this is the t, this is the t plus delta t. I want at the time t plus delta t, there must be n customer. Please listen the word. I want at the time t plus delta t, there must be n customers. So how there can be the n customers? How there can be the n customers? Please, you, if the nt is equal to n minus 1, so for the nt plus delta t, there must be, anyone please answer,
One birth.
one worth. There must be one worth. If there are n customers, then
Neither.
neither no
Neither
worth,
birth nor death.
right? No worth, no death. Then only it remain the n customer at the time t plus delta t. If the nt is equal to n plus 1, then we have the one worth or one death. Then there is the one death. Then we have the situation at the t plus delta t, there are n customers. Now here we define, this follows that in a small interval t to t plus delta t, we have the following three mutually exclusive and exhaustive events. Means from there we can understand, we can look, we can confirm, we can judge that all these events are mutually exclusive and exhaustive. Without other than these events, nothing can happen. We have either no worth, either one worth, or no worth, no death, or the one death. Other than this cannot happen, right? So these events are mutually exclusive and the exhaustive. What are the things? Exactly one worth, no death, because at a in the small interval only one event can happen. So one event is happening, worth of the customer. Exactly one death, no worth, and no worth, no death. No worth, no death. If you denote, if you denote this this by the event A, event event A, event B, and event C. If we denote these events as a ABC, ABC, so so if you want probability of exactly one worth, know that given there are n customers. So what will be the answer? What will be the answer? If I'm saying that this is the A, this is the B, this is the C, and this is the B. So exactly one worth. When there are n customers in the system, it will be the lambda n delta t. So it is equal to lambda n delta t. Probability B given there are n customer. Exactly one death, no worth. It is the mu n delta t, and probability C given nt is equal to n. No worth, no death. It will become the 1 minus lambda n plus mu n, lambda n plus mu n into delta t. Anywhere, if you feel any gap, please stop me and ask. Now, if I want at that time, at the at that time t plus delta t, there must be n customers. So here you can see Here I am computing the joint probability. It is the joint probability. Joint probability. Right? It is the joint probability where n is what? N is the number of customer. Discrete. Discrete random variable. Number of customers. Number of customers. And T is what? It is the continuous random variable. It is continuous random variable. Time. Right? It is the time. So here you can see we are dealing with the joint probability, more than one variable, more than one random variable, right? And random variable, both random variable are of different nature. One is discrete, one is continuous. So what is the meaning of the PNT? PNT. What is the meaning of the PNT? Can you tell what is the meaning of the PNT? Probability there are n customers, means state of the system, n customer at time t plus delta t. Probability that there are, means probability n t plus delta t is equal to n. At the time t plus delta t, there must be n customer. Now, using these events, whatever the events you have defined, how we can write? How we can write using this event, these events? Yes, anyone? If I'm saying that I want n t plus delta t is equal to n. So when it is possible, A intersection, or you can say A and means A. What is the A? What is the A? What is the A? Exactly one worth, right? Exactly one worth. Means if I want at the time t plus delta t, what should be the condition? Exactly one worth with n t is equal to n minus 1. Union B, exactly one death, and when this condition required, n t is equal to n plus 1. Union C, union C, and n t is equal to n. No worth, no death. We have this event, right? Now, if you want to compute its probability, so it means you have to compute the probability of this. Since ABC are mutually exclusive, so mutually exclusive means it can be written as A and n t is equal to n minus 1 plus, in the very first lecture I have told you, in the case of the mutually exclusive, it follows this addition property, B and n t is equal to n plus 1 plus P, C and n t is equal to n. Now, what is the meaning of the AND? AND means intersection, right? Intersection, PA intersection PB. P. So if you have to write the PA intersection B, it can be written as PA given B into PB from the conditional probability. from the conditional probability, we can write P of A give A and B is equal to P of A given B into P of B. So this can be written as P of A given nt is equal to n minus 1 into probability of nt is equal to n minus 1. P of A given B into P of B plus probability of B given nt is equal to n plus 1, nt is equal to 1, P of nt is equal to n plus 1 plus P of C given nt is equal to n, right? Nt is equal to n into probability of nt is equal to n. Clear? P of A give A intersection B can be written as P of A given B into P of B. Yes. Now please tell me what is the what is the formula for this? P of A given nt is equal to n minus 1. Please tell me. Here I have already written. Here I have already written P of A given nt is equal to n. It is what? Lambda n into delta t. So what will be the answer? Anyone please tell?
Lambda n minus 1 into delta.
Yes. It is the lambda n minus 1 into del t into probability that there are n minus 1 customers at the time t, means p n minus 1 t. Probability there are n minus 1 customer at the time t. Similarly, what is this pb given nt is equal to n plus 1? It will become, yes,
Mu n plus 1
mu
delta.
n plus 1 delta t into p of nt is equal to n plus 1, p n plus 1 t plus p of c nt is equal to n. P of c nt is equal to n is equal to
1 minus
1 minus lambda 1 plus mu n into delta t. So it will become 1 minus lambda n plus mu n into delta t into p n t. Clear this part? And it is what? It is the probability p n t plus delta t. T plus delta t. From here only we have started, na? Right hand side. P n t plus delta t is equal to n. That is the p n t plus delta t is equal to this. Now, if you multiply this one with this pn, and bring on the left hand side. So pn t plus delta t minus pn t, and divide whole equation by the delta t. So can you help me to write the right hand side? What will be the remain?
lambda n minus 1
Lambda n minus 1.
into p n minus 1
Correct. Right? Lambda n minus 1, pn minus 1 plus
plus
mu n
mu n
plus 1,
plus 1
pn plus 1 t minus lambda n plus mu n into pn. Correct? If you take delta t limit, delta t tends to 0. if you take the limit delta t tends to 0, what will be the, or here due to the means due to the higher order we have this higher order also. So as you take the delta t tends to 0, this higher order of the delta t uh, will become the 0, right? Because here in every expression we have not written, but in every expression we have the higher order of the delta t, higher order delta t. Here we have the higher order of the delta t. So when we take that delta t tends to very small, delta t tends to very small. So higher order of the delta t will be the is 0. So if you take the limit delta t tends to 0, can you recognize what is the left hand side?
First derivative.
First derivative
It
of,
is
correct, p and
Pn.
t. It is the d of dt of the p and t. First derivative of p and t, that is the p dash and t, and it is equal to minus lambda n plus mu n p n delta t plus lambda n minus 1 p n minus 1 t plus mu n plus 1 p n plus 1 t. So that is the first governing equation, and here the n vary from 1 to 1 to 1 2 3 and so on. Similarly, if you want to write, similarly if you want to write for the zeroth node d p0 t by dt, or you can say p0 t. So in this, if you put the 0, it will become lambda 0 lambda. Just for the hint I am writing, right, wrong thing here, mu 0 p0 t, right, put the n is equal to 0 plus lambda minus 1 p minus 1 t plus mu 1 p1 t. So can the number of customer be negative? Number of customer cannot be negative, right? Either we have the zero customer or the positive number of customers. So number of customers cannot be minus 1. It means this probability is equal to 0. This probability is equal to 0. And when there is no customer whom you will provide the service, when there is no customer, you cannot provide the service to anyone. It means what is the mu 0? What is the mu 0?
0.
It's 0. So when we have this, so it will become minus lambda naught p naught t plus mu 1 p1 t. Right? So for the 0, we have this equation. For the 1, 2, 3, and so on, we have this equation. So from here, if you write in fair form, so we have dp0t by dt is equal to minus lambda naught p0 t plus mu 1 p1 t, and dpnt upon dt is equal to minus lambda n plus mu n pnt plus lambda n minus 1 pn minus 1 t plus mu n plus 1 p p of n plus 1 t, p of n plus 1 t. Now from here, because this is the system of equation, you must require the initial condition. So what will be the initially we can assume there in any system at the time t is equal to 0, generally what we have? At the time t is equal to 0, condition may be any, but ideally, what is the condition at the time t is equal to 0? There is no customer. So initial condition can be at the time t is equal to 0, there is no customer. At the time t is equal to 0, there are n customers. So what should be the probability? At the time t is equal to 0, there is no customer. It should be the 1 and rest should be the 0. For n is equal to 1, 2, 3 and so on. So these are the initial condition. So now you have to solve this system of equation, this system of differential equation, right? Or this is known as Chapman Kolmogorov differential difference equation, right? These are known as the Chapman Kolmogorov differential difference equation, right? It is the differential with respect to differential generally we make for the continuous variable. So it is the differential with respect to time t, dy dt, and difference is the same as the differential but for the discrete. So with respect to n, number of customers, that's why we are writing na, right? Dpn by dt means here we have the means changes in n as well as in the t. So that's why we call it as a differential difference equation. And right, just wait a bit. Very important line is coming. So here we have the Chapman-Kolmogorov differential difference equation under the following initial condition. Just one more minute I will take. Now from here, if t tends to infinity, it means a large time. Large time means this is the transient equation. This is the, when we are writing the differential equation, we say they are the transient equation. They are the transient equation. When t tends to infinity, this change into the steady state equation. And when t tends to infinity, dy dt is equal to 0. Right? So in that case, the first equation dy dt will be the 0 is equal to minus lambda naught p naught. Now this will become the independent of t. When we say steady state means independent of t. So it will become lambda naught p naught plus mu1 p1 and 0 is equal to minus lambda n plus mu n pn plus lambda n minus 1 pn minus 1 plus mu n plus 1 pn plus 1. So now these are the system of equation. system of linear equations. System of linear equations. Instead of the differential equation, now we have the system of equation. System of equation, simple algebraic equation. Right now, what is the total probability rule? Can you tell what is the total probability rule? Right? What is the total probability rule? Normalizing condition. Anyone please tell what is the total probability rule? Sum of all probability. Sum of all probability. Sum of all probability. Sum of all probability is equal to 1. That is the summation n is equal to 0 to infinity of Pn is equal to 1. So we now solve the system of linear equation and with normalizing condition. With normalizing condition. If you want the steady state solution, if you want your analysis is steady state, then you have to solve the system of linear equation under the norm. The system of differential difference equation with initial condition. So in next class we start the solution of this. So that we have covered in these slides. Right? We have developed the right system of differential difference equation, and it convert to the steady state when we take the t tends to infinity. So now we have the steady state equation. We have the steady state equation under the normalizing condition. So up to this we have covered. In next class we compute the or we solve the solution. We compute the solution. Is there any doubt to understand how these equations are coming? Is there any doubt?
No, sir.
Okay, so now you can leave.
Sir, can you share these slides?
Slides we will not share.
Okay, sir. Okay.